Hi everyone, my name is Yiran Wang. I'd like to share with you our project, a sheet-based contact-aided compliant force limiting mechanism from Microneedle patches. And I will introduce our work through these 5 aspects. First is motivation. The Microneedle patch is an emerging technology of medical device, and compared to the traditional injection methods, it has many significant advantages. The middle figure shows the force displacement curve of one microneedle penetrating the skin, which shows a problem that when we use our finger to press the microneedle on our skin, it is really hard to control the maximum injection force. So we think that we can design a mechanical structure to limit the maximum input force through microneedle injection. And we will come up with 3 solutions. The spring and beam buckling solutions cannot meet the design requirements very well. So we finally chose the contact-aided compliant mechanism to further complete our design. Here is the sheet-based contact-aided compliant force limiting mechanism. At the initial stage, the contact rod is fixed below the component sheet, and the contact rod will go upward to deform the component sheet. It will generate a reaction force. So the more the contact rod moves upward, the larger the reaction force will become. But as the contact rod continues to move upward, it will go through the component sheet. At that point, the force will decrease to 0 instantly. That is how the force limiting function is achieved. And by designing different contact surfaces and different parameters of compliant sheet, the mechanism can meet different force limiting requirements. And based on this mechanism, we further proposed a force limiting microneedle patch applicator, which consists of 6 parts. The component sheet and the contact rod is in the middle of it. And this is cross-section view of the applicator. The contact rod is connected to the gate rod. And when we use the applicator, we first put the microneedle patch on the base, and hose of the barrel press it slowly. The force will increase until to the precise maximum force point. And after that, the contact rod will go through the component sheet. The force drops to 0. In that process, the injection process is completed. And we also perform the analytical mode to further validate the feasibility of our design. And based on the CPRBM method and the KKT principle, we analyze the deformation of the component sheet. And this is our experimental setup. And these 2 figures shows the force displacement curve of the applicator with different contact surfaces. And this is the experimental test further shows the force limiting function. Okay, for the application, the proposed contact-aided force limiting mechanism can not only be used in medical device, but also can apply in human-robot interaction and even in the seatbelt protection. Okay, lastly, let's come to the conclusions. In our project, we proposed a force limiting microneedle patch applicator. It is a compact structure and easy to use. As it without any electronic components, it is easy to manufacture and with low production cost. Okay, that's it. That's all I want to share. Thank you so much for your attention.